Hello wonderful person, this is Anton, and in today's video we're going to do a thought experiment. We're going to take our Earth and make it spin or orbit the opposite way from everything else and see what actually happens. Let's find out, and welcome to What the Math. Now we actually have at least one very famous object that does that in our solar system, and that's of course Triton, a moon of Neptune, the biggest moon of Neptune that orbits against the flow. You can see it going basically in the opposite direction. And we know for a fact that in a few billion years, Triton is going to slowly lose its orbit and collide with Neptune. So eventually, over time, it's going to lose all of its velocity and essentially collide with the beautiful Neptune. Now, will this happen to our beautiful planet Earth if it did the same around the Sun? Let's find out. Let's run the simulation for as long as we can and watch its orbital parameters and basically observe what's going to happen. We're going to go into the new simulation of a normal solar system, click on Earth, and basically inverse its orbit. And this is done by basically changing the inclination to 180 degrees from what it was before. Alright, so here comes Earth in its reverse orbit. It's going to be basically going against the flow, against every other planet. And I'm pretty sure that in the beginning, nothing will really change, because here the gravitational interactions with other objects are going to be very minimal. But with time, as the time passes, it's very likely that we'll probably start noticing something change in either eccentricity or the semi-major axis, or both, from our planet. So let's actually just run this for a very long time, or for as long as we can handle, and basically see what actually is going to happen. Now, if I were to look at semi-major axis, which is basically the average distance to the Sun, you'll notice that it's kind of slowly decreasing. Not very fast, but within just a few years, within about 30 years, it's already dropped just a little bit. So let's maybe accelerate this even higher, and we're gonna run this at almost a year per second. And within about the first 100 years, it looks like, well, it seems to be quite stable actually. I may have been wrong about it changing so fast, because it seems that as long as I run this at basically 10 months per second, it doesn't seem to change a lot. Now, there's a way to find out if it actually is going to change over time, and this way is going to be a little bit more extreme. We're actually going to do this one more time, but we're going to remove some of the planets here. It's like we're actually going to remove Mars and place the most influential planet a little bit closer to us, and that planet is, of course, Jupiter. Now, if there's anything that can deorbit Earth and make it collide with the Sun, it's going to be Jupiter. So let's actually take Mars out of this picture and move Jupiter significantly closer so that it's actually going to have a lot more effect on Earth. So here it is, practically the Earth's neighbor. It's going to have quite a lot of effect now. And now we're going to take a look at the semi-major axis again and just, I guess, watch the graph and see the changes in the graph as the Earth orbits relatively close to Jupiter. And well, this is about almost 100 years after that, and as you can see, the graph is still very stable. Earth is still in a very relatively stable orbit around the Sun, and even though Jupiter is actually a lot closer, it doesn't seem to influence Earth that much. And so the only way that Earth is actually going to lose its orbital parameters is if this picture here, if this particular setup is going to last for at least a billion years. So this would not really change anything in the short term, in sort of short time. As a matter of fact, I could place Jupiter even closer and it would still not really change the semi-major axis very much. I can show it to you by basically moving it even closer to us at a distance of about, I think this is about 0.1 astronomical unit. Now this would definitely do something. This has got to do something, right? So let's see what it does to our orbit here. And there we go. So now it starts changing. Now Jupiter is definitely having effect. But this would be the extreme scenario. So this would be over billions of years. Then the Earth would start losing its orbital parameters. and possibly get more eccentric orbit and eventually even collide with the sun, or maybe even get kicked out of the solar system. I don't think it's going to collide with anything, specifically Jupiter in this case, but it might actually happen. So let's see. Let's find out what happens. This is actually kind of interesting because there's a part right here where they approach relatively close to each other, and this is where Earth probably is going to lose the most orbital velocity. And as you can see, it's already lost a lot of velocity and gained a lot of eccentricity, so that its actual orbit intersects with Venus now. So this is what would happen over a period of several billion years. Now, in our solar system, we actually have several asteroids that orbit against the flow as well. And even though they're in a relatively stable orbit for now, over the next billion years, they're also going to lose their parameters, orbital parameters, and either escape into the outer solar system and basically escape the sun forever, or more likely, approach the sun really close and get basically burned into crisp and disappear, or essentially turn into comets, or maybe even collide with one of the larger planets like Saturn or Jupiter, which is what usually happens with these rocks. Alright, so this is, what, 300 years later. Earth has changed its orbit quite dramatically, but it's still not even close to the sun. But its periapsis is currently between Venus and Mars. And it's still relatively stable, though. It's still actually habitable, and there's still a relatively nice temperature, as you can see. Maybe a little bit hotter when it approaches sun between Jupiter and Venus, because you can kind of see this turns brown for a little bit. That's because it gets really, really hot. But with time, I think this will actually, this is very likely going to come really, really close to the sun and possibly even collide with it. Although, I'm not sure if this will actually happen. So let's run this a little bit longer and observe the effects, because right now it looks like this is actually a pretty stable orbit. And interestingly, due to Earth's mass, it is actually affecting Venus as well. Venus's orbit has been kind of changing a little bit. I think it's actually been retreating from the sun a little bit, because Earth has a lot more mass than Venus, and so it would have a lot more effect on Venus than Venus would have on Earth. So even though Jupiter was able to decrease our orbit so dramatically, for Mercury and for Venus to do the same, they would have to work on Earth for many, many years. And it's very likely that it's actually Earth that's going to change their orbital parameters, not the other way around. Because Venus, in comparison to Earth, is approximately 81% of its mass, and Mercury is even less than that. It's actually only about 5% of the Earth's mass, whereas Jupiter is like 320 times the mass of Earth. So here we might actually have to wait for literally a million in-game years before something actually happens, something interesting happens. Because right now, it seems that Earth is once again in a relatively stable orbit. So, what have we actually learned from this simulation? Well, there's really two things. One is that if Earth were to orbit in the opposite direction from everything else, it would still be fine for many, 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 many years. But over time, the effects would slowly decrease its orbit. It would slowly approach the sun closer and closer and closer, although this would probably take billions of years. And at some point, it might actually crash into the sun or get burned by the sun, or something dramatic might happen and it might crash into either Mercury or Venus. Now, this will once again take many years. It's not something that will happen just overnight. It's not something that you can panic about, but it's definitely something that is very, very likely going to happen. You can see that if I look at Earth's semi-major axis again, over time, it is slowly starts to decrease now. So there's actually a downward trend that you can kind of see it's going to happen more and more often as it approaches Jupiter, as it approaches Venus. But there's definitely a downward trend, meaning that over time, it is definitely getting closer and closer to the sun. Now, is the Earth habitable right now? Well, climate here goes from wintry conditions when it's far away to super, super hot conditions when it's really, really close to the sun. Now, the temperature, if you were to kind of check here, it goes up to about 45 degrees Celsius, or even higher. Look at that, 52 degrees Celsius. So even though there's still a little bit of ice left when we have winter, even those winters are ridiculously hot. and it's getting hotter and hotter every single year. You can kind of see that the water is even retreating in parts of Europe right there, and that's because basically it's going to evaporate eventually and turn our beautiful planet into a super dry, super hot desert-like environment where nothing can really survive. And eventually, of course, it's going to possibly die, either in a collision with Mercury or Venus, or in a collision with the Sun. And anyway, so that's really all I wanted to show you in this video, and maybe one day we'll actually run this for a few real-life days and see if it actually collides with the Sun, because right now, this decrease in semi-major axis, and basically the distance from the Sun to Earth, is very slow. I would have to run this for many days. Anyway, I hope you learned something from this video, and I hope now you know a little bit more about orbits, and specifically orbits of objects like Triton. If you've enjoyed this video, don't forget to subscribe, and don't forget to share this video with someone who enjoys learning science stuff. And come back here tomorrow because you're going to learn something new, something different, and something that you might enjoy as well. I'll see you guys in the next video. Thank you for watching. Space out, and as always, bye-bye. And let's actually accelerate this even higher, and then see what kind of menace we can create when the game can't even handle these. Oh, look at this beauty. This is gorgeous. This is tremendously beautiful. I'll see you guys later. Bye-bye.